Hi everyone. Let's not waste any more gigas and megas and bits and kilobits and everything and start working. Today we are going to deal with the friction force. Suppose I have a mass here and I pull it with external force F. Automatically, if I have friction, and I have today, the friction will be in the opposite direction, let's call it small f, because it contradicts this f. If I pull it here, the friction will be in the other direction. It is always opposite the tendency of the mass to move. If the mass wants to move here, the friction will be in the other direction. Now let's see what the friction is made from. First of all, obviously, if the surface and the mass are made out of, let's say, wood and wood, where you collide them together, it's a lot of friction. If the mass and the surface is metal and ice, like ice skating, it's very little friction. So, first of all, the friction depends on the surface, on the components of the surface. Secondly, if the mass is small, or the mass is big, obviously, it has something to do with the friction, but not precisely. Let's investigate a little more. We know that there's an mg force down here and the normal force here. The normal force indicates what the surface applies on the mass. If I apply force on the surface, it will feel exactly the same force, the normal force. So the friction depends on the normal force, because if the mass applies a lot of force on the surface, that means I have it press on it very hard, the friction will obviously be very bigger. Why don't we say that it depends only on the mg? Because in this case, obviously the normal force and the mg are the same, so n and mg is equal, so we can say n equals to mg. But in another case, suppose I lift with a rope or with another external force this mass upwards with another force, let's say another F1. So if I lift it a little bit, it will press lighter on the surface. So the normal force will not be mg, it will be less than mg. And the friction obviously will be less. Suppose I have an elephant here, just for imagination. If I have an elephant here, it will press, and I don't put an external force here, it will press on the surface with a lot of weight. So the friction, obviously, if you try to push an elephant, will be very hard. But if I pull the elephant with a, I don't know what, suppose I can pull the elephant up a little bit, not a lot, but a little bit, it will press lighter on the surface, so the normal force that the surface will feel will be much lighter and the friction will be much lighter. So the friction depends not directly on mg, it depends on the normal force. So the friction depends on two things: the surface, material, and the normal force. Let's put it in letters, in equations now. The surface we symbol with the letter mu. Mu is the coefficient of friction. We have charts. Every substance has its own mu. For example, metal and ice is a mu will be a very small figure, like 0.001, for example. Wood and wood, which is a lot of friction, will correspond with a mu, a very high mu. Why? Because it's a lot of friction. So mu it tells us, it indicates the amount of friction which is combined from the material of the surface and the mass. Mu. The other thing we said that the friction is made is composed from is the normal force. These two make the friction. So now let's go one step further. Suppose I have a box here, and I push it. When I push it, maybe it won't move. Why? Because the friction force in the opposite direction won't let it move. Suppose I push it a little more. Again, it won't move because the friction always adjusts to my force, it always adjusts to me. Suppose I push it very hard, it will start moving. Why it will start moving? Because the friction force can't overcome, it can't adjust to my force anymore, so the box will move. So we divide our friction, when we work with frictions, we divide two separate things. When the mass is at a place, when it's static, and when it starts moving. Let's talk about the static friction force. If I have a mass here, again, if I have a mass here, and I pull it with the force of F, external force, we said that there will be always a friction force in the opposite direction. Let's call it Fs, F static. This force can adjust to this force up to a point. If I pull it in a small force, it will adjust to me. A little big, it will adjust. More. Eventually, when I pull it hard, it can't adjust to me anymore. Why? Because it has a maximum figure that it can be. So this maximum friction, I want to know how to calculate it. And to calculate it, the equation is Fs max equals to mu static multiplied by the normal. This is the first, why did I do that? This is the first equation we are going to use. And we must understand it very carefully. It doesn't mean that the friction is always like that. It means that it can be maximum like that. For example, let's do a very small example with numbers. For example, let's say my mass is 2 kilograms and the mu static is 0.2. We know the force here down here is 20 newtons and this is the normal. And because it doesn't go up nor down, the normal force will obviously be 20 newtons. The F static max will be mu static multiplied by n, which means 0.2 multiplied by 20, it's 4 newtons. What does it mean, these 4 newtons? It means if I pull this mass with a force of F, suppose 2 newtons, obviously the friction will be, let's say Fs, it will be in this direction. If F will be 2, this one will be 2. F will be 3, this one will be 3. 3.9, 3.9. It will always adjust to me, and according to the third law of Newton, it won't move. 4, 4. 4.1 or 5 or any other number higher than 4, it will start moving. It won't be static anymore, it will be kinetic. So the kinetic friction force will be mu k multiplied by the normal. It's the kinetic friction force. These are the difference between them. This I use when the mass is static, doesn't move. This I use when the mass is kinetic. Let's show in the same example. Let's say the mu kinetic is 0.1. So the F kinetic will be mu kinetic multiplied by the normal force, which is 0.1 multiplied by 20. It's 2 newtons. So what does it mean? As we said, if the mass is static, doesn't move, if I apply 3, it will give me back 3. 4, it will give me back 4. 4.1, it can't give me any more because 4 is the maximum it can give me. So if I apply 4.1, the mass will start moving and the friction force will be automatically kinetic. It will be 2. So if the F will be 4.1, the friction will be kinetic. It will be 2 newtons. And what will happen to the mass? Obviously, it will accelerate this direction And if I want to calculate the acceleration, I will do what I did in all other lessons that we had. This minus that equals to ma. Okay. I want to show you one more thing that you see where it comes from. Why does it work like this? If we look, again, let's draw this picture. This is the mass, this is the surface. Suppose the mass is on the surface, is static, it doesn't move. If we take a magnifying glass and zoom this place, what we'll see the surface is not so flat. It is composed with bumps. And the mass sits like that in the bumps. This is the mass. And this is the surface. So when I pull the mass to the right, for example, this place will meet this one, and this will meet this one, and this will meet this one. And they will all apply force on the bumps. And the bumps, what will they do? They will apply force exactly in the same direction, exactly in the same magnitude, opposite direction. This is exactly what the friction force is. It's all these little forces that the bumps apply on the mass. Now, if I pull it very lightly, it is almost, I lift it a little bit, but it's still in the bumps. I pull it a little harder, I lift it more. I pull it a little harder, I lift it more. I pull it with 4 newtons, like in the other example, I lift it above the bumps. So the mass will sit like that. Above the mass, above the bumps. And when I pull it now, the friction force will be much less because it now collides only with the top of the bumps. It's not inside the bumps. So what does the Fs max tells us? It tells us how much force I need to apply in order to lift a little bit, lift the mass up the bumps, and then it's free to move. And the kinetic force tells us that when the mass is already on the bumps, up, not inside them, the friction force is this one, and it will stay on with this friction force until it stops and it sinks back in the bumps, and then I need to, again, lift it up, and so on. So this is what is behind these formulas. Okay, so now let's see how we solve problem. We'll go very slowly in order to see how to work with them. So we only have 2 equations. Fs max equals to mu static multiplied by normal. F kinetic equals to mu kinetic multiplied by the normal. Okay, a lot of examples. Let's start with this one first. I have a mass here, 10 kilograms. Let's say the mu static is 0.5, the mu kinetic is 0.2. And I pull it with the force of F. I want to know everything. How do you deal with problems with friction? First of all, you apply forces with no friction, without the friction. So obviously I'll have 100 Newton here, normal force there. Now I apply the friction force. The friction force will always be against the tendency of the mass to move. This mass will obviously want to move to the right, so the friction force will be here. I don't know if it's kinetic, I don't know if it's static. I'll ask questions and then we'll see. Before anything you do in these exercises, always, this is my advice to you, write for yourself the Fs max and the Fk. Fs max is mu s multiplied by n. In this case is 0.5 multiplied by 100, because n and 100 are the same. It's 50 newtons. F kinetic is mu kinetic multiplied by n, which is 0.2 multiplied by 100, which is 20 newtons. Now we'll start asking the questions. First of all, what will happen if F equals, let's say, 30 Newton? What will happen? This is our first question. And the mass is static. If F is 30 newtons, the F static mass can adjust up to 50 newtons, which means that it can be also 30 newtons, and this one won't move. So F static will not be max, it will be 30 newtons, and the mass won't move. Let's take another example. What happens if F equals to 45 newtons? If I pull it with 45 newtons, the friction again can adjust to me because the maximum it can adjust is up to 50. So it will be 45 newton and the mass won't move. What happened when the F is 50 newtons? When I pull it with 50 newtons? This is the extreme case where the statics, the friction can adjust to me exactly with the 50. So the friction will also be 50 newtons, and this mass is almost ready to move. It's as if I lifted up the bumps and a little and it will move. So what happened now when I apply 60 newtons? Well, when I apply 60 newtons, it means I lift it from the bumps and now it's ready to move. So if it's ready to move, the force will not be static anymore, it will be kinetic. And what I'll do is I'll write the second law of Newton. All the forces in this direction, which is 60, minus all the forces in this direction, which is 20, because it's kinetic now, equals to ma. M is 10, a is a. So this mass will accelerate with a equals to 4. These are all these examples show us what happens to the mass in different forces we apply. If I apply force, if I pull it with a force less than 50, the friction force will adjust to me, and according to the third law of Newton, the mass won't move. If I pull it with exactly the 50, it will adjust to me, but one and it will move. And if I apply 60, obviously it's over 50, so it moves. But when it moves, the friction will not be static anymore, it will be kinetic. It will be 20. Okay, that's our first example. Let's go on. Okay, let's do this example. Let's say this is, let's write numbers. 2 kilograms, 4 kilograms, mu statics is 0.5, mu kinetic is 0.2, again. Now when we say mu and mu, it means only in the surface, not in the air, because in the air we don't feel any friction yet, maybe later, not now. Okay, how do I deal with these problems? First of all, it doesn't matter what they ask me. First of all, I apply forces without the friction. So obviously, this will be pulled by 40 newtons, T, normal force, 20 newtons. Now I ask myself, which way this system tends to move? Obviously, it tends to move downwards. So if it wants to move this way, the friction force will be that way, against the tendency of this system to move. This one doesn't feel any friction force because it's in the air. Friction always when you have normal, when you are on the surface. Now, it doesn't matter what they ask me, I always write myself these two equations. I want to know what the Fs max is and the F kinetic is. Fs max is mu s multiplied by n. In this case is 0.5 multiplied by n is 20, which is, so this is 40 newton, so this is 10 newtons. F kinetic is mu kinetic multiplied by n, which is 0.2 multiplied by 20, which is 4 newton. Now what these numbers tell us, if this system is at rest mode, resting, doesn't move, in order for it to move, I need to apply more than 10 newtons and then it will move. And if it moves, this friction force will not be static anymore, it will be kinetic. Now I look at the system, at the line of movement, obviously this way, and I ask myself, what is the force that is pulling, external force? I neglect the internal force. What is the external force that pulls this system? It's 40. Is 40 bigger than the maximum friction force, static friction force can be? Yes, because the maximum can be 10. 40 is bigger than 10, which means this system will move. And if it moves, the friction will not be static anymore, it will be kinetic. So this is a check I always have to do. I have to make sure the external force that pulls the systems overcomes the biggest, the maximum friction force, static friction force that can be, which is 10 over here. And if so, the system will move. So if it will move, the friction force will not be static anymore, it will be kinetic, and I use the 4. So if what they can ask me what will happen to this system if it will move, and if it does, what's the acceleration. So from here we understand that it will move, and then we want to find the acceleration. And if we want to find the acceleration, let's look at it as a whole. We'll say 40, all the external forces here, minus all the external forces here, which are the friction force, but it's kinetic, equals to the mass of the system, 6, multiplied by A. So 36 equals to 6A, A equals to 6. If I want to find the tension, I write Newton law, for example, on this one. I'll say 40 minus T equals to MA, and I know the A, so I can calculate the T. Okay, this is another example how to deal with friction. More. Three. Let's do exactly the same in the opposite direction. Okay, let's say this mass is 10 kilograms, this mass is 5 kilograms, and the mu static is 0.5 and the mu kinetic is 0.1. Now let's reduce it to 2. Okay, I want to know exactly the same question, what will happen to the system. First of all, we apply forces without the friction. So, 20 newtons here, T there, T, and 100 newtons. Now we apply the friction force. We see the tendency first of this system to move. This system wants to move that way, so obviously the friction will be here. I don't know if it's kinetic, I don't know if it's static. Let's find what the Fs max is and the Fk is. Fs max is mu s multiplied by n, which is 0.5 multiplied by 100, 50 newtons. Fk is mu k multiplied by n, which is 0.1 multiplied by 100, 10 newtons. Now, let's ask ourselves the question. We want to know if this system is going to move. The pulling force, external force, is 20. The maximum friction force that can be is 50. So 20 can't overcome 50. But the friction won't be 50, because if it was 50, it will be absurd. Why? Because 50 will be bigger than 20, it will move this way. Obviously, this system can't move this way, it can only move that way. So what will happen? The friction will, the maximum friction can be 50, but it can adjust to the pulling force up until 50. So if the system is pulled by 20, the friction force will be static, not static max, but it will be 20 newtons, and the system won't move. If I want to find tensions, I know the system doesn't move, so T equals to 20, T also equals to 20, T equals to 20, and it won't move. Acceleration will be 0. So this is another example that systems don't have to move. The force can adjust to the pulling force up to 50. Suppose this force was 60. If it was 60, then it will overcome the maximum friction force that can be. So the system will move, and the friction will not be 50 anymore, it will be 10. And we can find acceleration accordingly. More. Four. Okay. The same with a little twist. Okay, let's say this mass is 10 kilograms, this mass is also 10 kilograms, but I apply force here, external force, with, let's say, 120 newtons. Mu static is 0.5, mu kinetic is 0.2. And again, I want to know everything. I want to know if the system will move, and if it does, where, and what the acceleration, and if it doesn't, what the friction is, everything. So, first of all, I apply forces with no frictions. 100 newtons, normal, T, 100 newtons. Okay, now I ask myself, which way this system wants to move? External forces is 100, external forces is 120. So what do we conclude from that? It wants to move that way. So the friction will be this way. But still, I don't know if it's kinetic or static. We'll check. So I write myself these two. I always do. It's a good way to deal with these problems. Fs max is mu static multiplied by n. In this case, 0.5 multiplied by 100, 50 newtons. And if it's mu kinetic multiplied by n, it's 0.2 multiplied by 100, 20 newtons. Now, let's ask ourselves this question. The external forces is 120, and the maximum that can be here is 50, but there is also 100 here. So I pull it from this position with 120. 100 I already have, and the maximum that this one can give me is 50. It doesn't have to give me all the 50, but it can give me up until 50. So if I put it at 120, and 100 is already there, the friction can adjust 20 from the 50, and the system won't move. So this system, on the other side, if the pulling forces from this side is 120, from this side I have 100, and also I can use 20 from the 50, so the friction will adjust and take only 20 from the 50, and the system will not move. And the friction will be static, not static max, static with only 20. Okay, what happened? Let's say, another problem. Now F, I decided to be not 120, I want it to be 200. Now if it's 200, what will happen now? I have 200 this direction, and in the other direction I already have 100, and the force, friction force, can adjust up to 50. But even if it gives me 50, 200 overcomes 50 and 100. So it will move. So I have maximum here, 100 plus 50. So the system will move. And if it will move, the force here will not be static anymore, it will be kinetic. And if I want to find the acceleration, I can look at the whole, I can look each mass separately, it doesn't matter, let's look each mass separately. If I look each mass separately, I will write 200 minus T minus Fk equals to 10A. 200 minus that equals to MA. And then on this one, because I know that it moves up this direction, T minus 100 equals to MA, always. Again, 10 multiplied by A. If I add them up, I will get 200 minus 100 minus Fk equals to 20A. And this equation is exactly the same equation as I would have gotten if I looked at this system as a whole, because I would say all the external forces 200 minus all the external forces, which is this one and this one. Kinetic force, friction force is external force. 100 minus Fk equals to the mass of the system, which is 20 multiplied by A. So F kinetic, we know it's 20. So 200 minus 100 minus 20 is, I think, 80. Equals to 28, A equals to 4. So now I know what the acceleration will be. What else I can ask you? I can ask you, what F do I need in minimum F, because I can use multi-F as much as I want, what the minimum I need in order for this system to move that way. So in order for this system to move that way, I need to overcome the 100 and the maximum force that can be, the static force, so, which is 50. So in order for this system to move that way, the pulling force must be over 150. If it's exactly 150, we don't deal with these kind of problems. It's on the verge of moving, you just foo and it moves, okay? So F must be 150 and higher in order for the system to move that way. Okay, one more. Okay, 5. Let's suppose I have this system. This is M equals 10 kilograms, M equals 20 kilograms, F equals to 40 newtons. And mu static is F 0.5, mu kinetic is 0.1. But I tell you another information about the system, that it moves this way. It moves that way. Why? It doesn't matter why. Someone kicked it, like that, kicked it this way, and it moves this way. If it moves, I don't have to deal with a static force, because it's not static, it's kinetic. It's automatically has kinetic forces in it, friction. But still, always do both of them. I want to know, and then we'll ask questions. F kinetic. But now, just one more thing, I have two friction force, this one and that one. Let's call it N1 and N2. First of all, we apply forces and then we'll write. Down here is 100 newtons. Up here, N1. N2, 200 newtons. Obviously T and T. Now, they tell me that this system moves that way. If it moves that way, I don't even have to think. The kinetic force must be kinetic, will be here, let's call it F1, and here, F2. And they are all both kinetic forces. Why kinetic? Because the system moves. Let's find what F1 kinetic is, what F1 static mass is, what F2 kinetic is, and what F2 static max is. F1 kinetic is mu multiplied by N1. In this case, mu is kinetic 0.1, mu kinetic. 0.1 times multiplied by 100 is 10 newtons. This one will be mu static times N1, which is 0.5 multiplied by 100, which is 50 newtons. This will be mu kinetic multiplied by N2. Mu kinetic is 0.1 multiplied by 200, which is 20 newtons. And this will be mu static multiplied by N2. Mu stat is 0.5 multiplied by 200, which is 100 newtons. Now let's ask questions. We know this system will accelerate with a negative figure because it slows down. If it moves that way and the friction is this way and someone else puts it all again to this same direction, obviously it will slow down and stop. So first question I want to know, what's the acceleration? Okay, so we can look at the whole. Let's look one each at a time, one mass at a time. The line of movement is this one. So if I write equation on this one, I will write 0 point, because there's no force here, minus T, minus F1 kinetic, which is okay, let's write F1 kinetic equals to MA. Let's write forces on this one. T minus 40 minus F2 kinetic equals to MA. Again, if we add them up, T and T goes, we'll get 0. minus 40 minus F1 kinetic minus F2 kinetic equals to 30A. And this equation I would have gotten if I looked at this system as a whole. I'd say all the pulling forces, which is 0, minus all the external forces, which is that, and that, and that, equals to the mass of the system multiplied by the acceleration. Okay, this one is 10, this one is 20, so I'll get minus 70 equals to 30A. So A equals to minus okay, this is A. The minus says that it slows down. Every second the velocity decreases by this number. We'll deal with this later. Once this system, we know the system slows down and eventually it will stop. And I want to know what will happen after it stops. After it stops, I want to know, will it accelerate, let's write it, after stopping, will it accelerate again? Okay, how do we know that? First of all, we look at the system again. After it stops, the tendency of this system, let's draw it again. After it stops, it's static now. The external force is still 40. But what will happen now, something very interesting, the tendency of this system to go is now to the right. So the friction force will be to the left. F1, F2. And now I need to check whether the 40 can overcome the maximal friction force that can be. If it overcomes, it will move and these forces will be kinetic. If it can't overcome, they will adjust to the pulling force. So, I have all the numbers, I don't need to calculate, I just need to see if 40 can overcome. Does 40 overcomes these both frictional forces, which the maximum frictional forces, static frictional forces, which are 100 plus 50. Does 40 overcome 100 plus 50? Obviously not. So what will happen? The system won't start moving again, and the friction will not, obviously will not be 50 and 100, they will adjust. It doesn't matter how, they won't ask you this question, but they will adjust accordingly. So both of them, the sum of them will be 40, and the system will stay resting. What happens if I do want it to move? How much force do I need to apply in order for it to move now? I need to overcome these two. I need to overcome this 150. How do I overcome it? If I pull it with 151, for example, it will overcome them, and what will happen now? Obviously, these forces will be kinetic forces, and the system will accelerate that way. And if I want to calculate the acceleration, again, that minus that equals to ma, that minus that, exactly like we did before. Okay, more. Okay. Let's 6, I think. Okay, let's do more complex system like that. Mu static equal to 0.5, mu kinetic equals to 0.3. Okay. M1 equals to 5 kilograms, M2 equals to 3 kilograms, M3 equals to 2 kilograms. Imagine I wrote kilograms. Okay. Again, I want to know this system doesn't move. I want to know if it will move, where will it move, acceleration, everything. Again, forces. 20 newtons, T1, remember 2 ropes, 2 T's. T1 and 2, 30 newtons, T2, T2 and 2, and 1, 50 newtons. Okay, first of all, I remind you, I apply forces without the friction. After I do so, I ask myself where this system is going to move. It wants to move here, obviously. So the friction forces will be at the opposite direction on both of them. F2, F1. I still don't know if it will move. Why I don't know? Because I don't know if this 20 Newton can overcome both of the friction, maximum friction force. So I calculate, I do F1 max, F1 kinetic. And here I'll do F2 static max, F2 kinetic, F1 static max. Okay, F1 is mu static multiplied by N1. Mu static is 0.5 multiplied by 50 is 25. I don't need to continue to understand that it won't move because 20 can't overcome 25. So let's adjust a little the exercises to make it more interesting. Let's put it, let's say this is 7 kilograms, which is 70 newtons. Okay, I adjust it a little bit in order to make it interesting. F1 kinetic is mu kinetic multiplied by N1, which is 0.3. I don't like this 0.3. It's not good for me without my calculator now. 0.2 multiplied by 50. So 0.2 multiplied by 50. I don't like it also. No, it's okay. It's 10 newtons. Okay, let's do this one. This is mu static multiplied by N2. Mu static is 0.5 multiplied by 30, which is 15 newtons. And kinetic is mu kinetic multiplied by N2 is 0.2 multiplied by 30, it's 6 newtons. Okay, now let's ask the questions. This system is pulled down by 70 newtons. The maximum external friction force maximum that can be is 25 plus 15. So 70 overcomes 25 plus 15. Yes, it does overcome them. So the frictions, the maximum friction, static friction forces can't adjust to it. If they can't adjust to it, this system is going to move. And if it moves, as we said, the friction will not be static anymore, it will be kinetic. So I want to know what the acceleration is. Let's treat each object at a time. If I write the equation on this one, obviously it accelerates to the right. So T2 minus F1 kinetic equals to 5A. That minus that equals to 5A. If I apply forces there, is T1 minus T2 minus F2 kinetic equals to 3A. That minus that equals to 3 multiplied by A. And if I apply forces the equation here, it will be 70 minus T1 equals to MA. When I add them up, all the T goes, and I'll get 70 minus F1K minus F2K equals to 15A. And this equation, I can know it without doing each at a time, because 70 minus that, 70 minus that equals to the sum of mass, exactly 15A. Okay, this one is 10, this one is 6, 10 and 6, and if we want the acceleration, I didn't bring my calculation with me, so even better. 60, 54 equals to 15a. A equals to 54 divided by 15. I don't know. Okay, if I want tensions, again I place it here, find tensions, it's easy from here. Okay, one more. So 7. Okay. F, M1 equals to 5, M2 equals to 15 kilograms. Let's apply forces and then ask questions. Mu S equals to 0.5, mu K equals to 0.1. Okay, downwards, 150 newtons. Up, T, and 50 newtons. Okay. First of all, I can't apply the friction force. Why? Because I don't know which way this system is going to move. Why? Let's investigate a little bit. They didn't tell us anything about this external F force. If this force is less than 150, the tendency of this system is to move that way, and obviously the friction will be here. If F is bigger than 150, the tendency will be to go this way and the friction will be that way. So unless they tell us something, we can't put the friction force, we don't know which way to put it. So let's ask all the questions that can be. First questions I want to, before I do, I do want to know what Fs max is, even though I don't know the direction, but I want to know the value. Mu static multiplied by n, mu kinetic multiplied by n, 0.5 multiplied by 50 is 10, 0.1 multiplied by 50 is 5. Okay, now let's ask questions. I want to know the F minimum that I need in order for this system to move that way. This is the first question. What is the minimum force I need in order for this system to move that way? Now, obviously, why won't